Hello, everyone. Today, I will introduce the charger system. Today's report mainly covers the following topics. First, we will give an overview of charger. Then, we will introduce how to link RTK charger to app charger. And finally, we will introduce our internal charger. This report is mainly introductory, and you can learn more about the technical details in the SDK online documentation. First, let's introduce overview. Let's introduce the first part of the charger system overview. As shown in the figure, the charger system is divided into upper and lower layers. The upper layer is the app charger, which is responsible for reporting the state of charge and charger state to other modules in the app layer. The lower layer is the charger implementation, which is usually an internal charger, but an external charger can also be used instead. There is an RTK charger source file in the app project as a wrapper for the internal charger because the internal charger was placed in ROM. On the other hand, the external charger should be implemented in the app project completely. Next, we will introduce how to link RTK charger with app charger. This section describes how to link the RTK charger to the app charger. The charger can choose to use an internal charger, but it can also choose to use an external charger. If you want to use an external charger, you should link it with app charger after completing the driver of the external charger. Regarding the internal charger, the RTK SDK has already implemented it in the RTK charger source file. If you want to use the internal charger, set the macro RTK charger enable to 1, otherwise, set it to 0. The main task of the internal or external charger interface is to provide the app charger with the state of charge and the charger state through call and callback methods. By call, it's necessary to add the charger API to the functions app charger get charge state and app charger get SoC. By callbacks, register callbacks to the charger module, and these callbacks will eventually send state of charge and charger state in the form of messages using the function app IO send. These messages will be handled in function app charger handle MSG. Then, app charger is responsible for reporting the information to other application modules. Next, let's introduce internal charger. Next, let's introduce the internal charger system. The internal charger system includes the charger module and the discharger module. The main functions of the charger module include battery charging, error handling, state of charge tracking, and status reporting with a callback function. The main functions of the discharger module include state of charge tracking and status reporting with a callback function. When the charger module is running, the system will not be allowed to enter low power mode. When the discharger module is running, the system is allowed to enter low power mode. The charger module and discharger module will not coexist. The charging process of the internal charger system is divided into 3 stages. The first is the pre-charge stage, during which the battery is charged with a very small current, usually only 1/10 of the normal charging current or even less. When the battery voltage exceeds the pre-charge voltage, it is then allowed to enter the fast charge stage. In this stage, the charging current should be limited, and the charging voltage should be limited to the termination voltage. In the early stage of fast charge, the charging rate will be bound by the current limit. When the battery voltage is nearly at full voltage, the charging current will gradually decrease, and the charging rate will be bound by the limit voltage. When the charging current is lower than the end current, it means that the battery is fully charged. Set the current upper limit to 0 to end the charging. As shown in the figure, the internal charger system needs to be configured through the MCU config tool. For detailed information, please refer to the charger chapter in the MCU config tool user guide. This section lists the APIs of the internal charger system. The internal charger source code is implemented in the ROM. The API declaration is located in the charger API header file. Through these APIs, you can control the internal charger system and obtain its status. For a detailed description of each API, please refer to the SDK online documentation. This section lists the APIs of the internal charger system in the charger utils header file. This set of APIs is a functional supplement to the existing interfaces in the charger API header file. Through these APIs, you can obtain information such as the configuration and status of the internal charger system. For a detailed description of each API, please refer to the SDK online documentation. This section introduces the difference between the battery open circuit voltage and the VBAT terminal voltage. The API provides the battery's open circuit voltage, not the VBAT terminal voltage. During charging, the battery's open circuit voltage equals the VBAT terminal voltage minus the charging current multiplied by the battery's internal resistance. During discharging, the battery's open circuit voltage equals the VBAT terminal voltage plus the discharging current multiplied by the battery's internal resistance. Note, the higher charging current leads to a higher voltage division in the internal resistance of the battery. To confirm the actual OCV when charging, users could measure the battery voltage separately when cutting off the charging line. That concludes our presentation. Thank you for your attention.